So let's talk a little bit about cryptography. Cryptography is the science of encoding and decoding information. The practice has been used for centuries, from sending secret messages to military generals to keeping your password safe when you log into Facebook or Google. One form of encryption, or the encoding of information, is Caesar's cipher, named after Julius Caesar. Caesar's cipher works by taking a series of letters and substituting every letter with another letter a fixed number of positions down the alphabet. When the cipher reaches the letter Z, a key of 1 will loop the plaintext back to A. So let's start with some simple examples. Let's say the letter A, and we're working with a key of 1. The A will shift to a B. Let's say our key is 3. Then we end up having our A shift 3 positions down the alphabet to the letter D. So let's say we start with the word cat, and we're working with a key of 5. The C ends up shifting to an H, the A ends up shifting to an F, and the T becomes a Y. And this is our encryption, HFY. Now let's try a slightly more difficult example, something that requires Z to A looping. Let's say we're given the word computer, and we're working with a key of 7. We look at the first letter, a C, and we shift it down 7 positions in the alphabet to the letter J. We do the same with the O, and it goes to a V. M and P follow suit with T and W. Now U is our first special case in our encryption. It requires Z to A looping. That's just a way of saying that once we reach the letter Z, we go back to the letter A. So U ends up going to the letter B, and T ends up going to the letter A. ENR, finish it up, and here we are with our encryption, JVTBLI. To shift back to our original text, we only need to shift our ciphertext 26 minus 7 positions, or 19 positions, and we're back at the beginning. Unfortunately, Caesar's cipher is not the most secure form of encryption, as exemplified by its simplicity. There are only 26 possible shifts, 0 through 25, of which 1 will decrypt the ciphertext back to its original plaintext. It'd be relatively easy for a human, let alone a machine, to decrypt text ciphered with Caesar's shift. Caesar's shift is but one method of encryption and is often incorporated as a step in more complex ciphers, such as Vigenère's cipher, but more on that at another time. Well, that's all, and thanks for watching.